EX6, that is hexahalides. Particularly, which one is more stable? Sulfur hexafluorides. Second one is going to be white. చిన్న చప్పి సార్. Small. So and another one is called EX4. EX4 important. SF4. So what is the geometry, and we have discussed. And the next one is going to be EX2. Next, the last one is going to be monohalides. Monohalides always exist as a dimeric. In a form? Dimeric. So dimeric form that will undergo both disproportionation form. One species will be oxidized, the another one is going to be reduced. So that's all about the properties of group 16. So next we are going to discuss about. Thank you so much. Next we are going to discuss about group 17 elements. Group 17 elements. So group 17. So what is the general electronic configuration of group 17? Electronic configuration. Electronic configuration. Electronic configuration of group 17. NS2, NP5, NS2, NP5, NS2, NP5. So what are the elements that is present in group 17? What are the elements that is present in group 17? Huh? So fluorine, bromine, iodine, At, that is astatine. Okay, At. So in this case, what is the electronic configuration? 2s2, that is helium, 2s2, 2p5. For chlorine is going to be 3s2, 3p5. Okay, this is going to be a neon. And similarly the other configurations are, you please fill this. This is going to be 4s2, 4p5, 5s2, 5p5, 6s2, 6p5. Is it clear? You please fill this. A noble gas core. This is going to be noble gas core. Noble gas core in another LEGO. And what is the atomic number in this case? Atomic number 9. In this case 17. Enna add pannu? 8. In this case 18 add pannu? 35. Again you have to add another 18. 53. In this case 32 add pannu? 85. Is it clear? The magic number 8, 18, 18, 32. Okay, so apart from this, okay, this last one is going to be the radioactive element. This is a radioactive element. Radioactive element. It's going to be a radioactive element. Next important point regarding this. So these group 17 elements are collectively called halogens. Group 17 elements are collectively called halogens. So what is the meaning of halogens? Halogens means, any idea? What is the meaning of halogens? No, halogen would a name. What is the meaning of halogens? Halogens are nothing but salt producers or salt forming. Salt producer. Or salt forming metals or salt forming elements. There you go. Halogens are called salt producers. Okay. Halo means salt and genes means bond. Halo means salt and genes means Greek word. Halo means salt and genes means bond. That is salt producers. Okay, halogens means salt producers or salt forming elements. And we know that halogens are highly reactive. Halogens are highly reactive. Highly reactive. Metal or non-metal? Highly reactive non-metal. Highly reactive non-metal. Please note this. Highly reactive non-metals. Next is occurrence. Just to please read this. Okay, full detailed read paniko. In this case, occurrence. So this is going to be fluorine. Fluorine. So mainly as an insoluble fluorides. எப்படி கிடைக்கும்னா ஃப்ளூரைட்ஸாக கிடைக்கும். Mainly as an insoluble fluorides. For example, calcium fluoride. இதுக்கு பேர் ஃப்ளூரோஸ்பர்னு பேர். இதோட source. Next we have a sodium aluminum, that is இதுக்கு பேர் cryolite. Cryolite எங்கே யூஸ் பண்ணும்? Any idea? Cryolite எங்கே யூஸ் பண்ணுவாங்க? Cryolite மெட்டலர்ஜி படிச்சிருக்கியா? மெட்டலர்ஜியில் cryolite எங்கே யூஸ் பண்ணுவாங்க? Any idea? மெட்டலர்ஜியில் cryolite எங்கே யூஸ் பண்ணுவாங்க? Next one is fluoroapatite. This is going to be, the general formula is going to be calcium phosphate. This is the formula for fluoroapatite. You just remember these are the fluoride source. Okay, fluoride source. So this is going to be in the formula கிடைக்கும் அப்படினா in the form of fluorides-ல கிடைக்கும். So occurrence is going to be fluorine in the form of fluorides. Examples: calcium fluoride, இதோட பேர் cryolite, இதோட பேர் is fluoroapatite, இதோட general formula. Okay, so that is apatite na இது formula. Is it clear? இங்க X2 ன்னு இருக்கும். Is it clear? இங்க X2, இதுல fluorine இருந்தா fluoroapatite. Okay, the rest you can read. Okay, these are the few things that you have to remember. Next we are going to discuss about atomic properties. That is the most important. Atomic properties are most important. இதுமே is atomic property. Now we have to give answer for this, okay? Because already you might have studied in periodic properties. Atomic properties. Atomic property, first one is going to be radius. Atomic and ionic radius. Atomic and ionic radius. Atomic and ionic radius, is it clear? So what is the general trend? Left to right pona, radius decreases, down the group pona increases. Suppose down the group, if you move from left to right, if you move from top to bottom, that is fluorine to iodine. Fluorine to iodine, that is atomic number increases, radius also down the group increases. Down the group, radius also increases because number of cells are increasing. Number of cells increase, atomic or ionic radius, down the group increases. Is it clear? But down the group, radius always is going to be increases. This is the exceptional criteria. This smallest size of fluorine, this largest size in iodine. Is it clear? Because the 18 acetine radioactive element generally discuss pandradilla. Is it clear? So this is a point. Second point is going to be ionization enthalpy. Ionization energy or ionization enthalpy. Ionization enthalpy. Okay. So ionization enthalpy, what is the trick we have to use? Ionization enthalpy is inversely proportional to atomic radius. Ionization enthalpy is inversely proportional to atomic radius. Obviously down the group, the radius increase, ionization energy decrease. Is it clear? Among this one, ionization energy ionization energy for fluorine is going to be more because size is going to be very small. Size is going to be very small. Ionization energy is going to be less in iodine because size is going to be larger. Ionization energy is inversely proportional to atomic radius. But down the group, atomic radius increases, ionization energy decreases. Is it clear? That is a point. Next important property is going to be electron gain enthalpy. Electron gain enthalpy. Third atomic property, electron gain enthalpy. Electron gain enthalpy, which is the most important. Okay, most important. Is it clear? So, can you tell me which one has the highest electron gain enthalpy among highest electron gain enthalpy? Chlorine. So, the order in that Cl, F, Br. So, what is the order? Electron gain enthalpy, the answer is going to be chlorine. Is it clear? Yes or no? Why? Why it has a more electron gain enthalpy? Electron gain enthalpy is nothing but electron affinity. Why it has a more electron affinity when compared to fluorine? This is due to size. This is because of size. So what is the trick? What is the trick? Third period as well as second period. Which one has a more electron gain enthalpy? Third period versus second period elements. Third period versus second period. Which one has a more electron gain enthalpy? Third. For example, fluorine and chlorine. Which one has a more electron gain enthalpy? Chlorine. When compared to, similarly, group 16, sulfur and oxygen. Sulfur has more electron gain enthalpy when compared to oxygen. Oxygen. Is it clear? So please do remember. Is the reason? What is the reason for that? Due to size. So size அதிகமாக இருக்கிறதுனால electron gain enthalpy relatively high when compared to fluorine. Relatively high when compared to fluorine. Is it clear? Please note this point. It is important. General trend என்ன அப்படினா electron gain enthalpy left to right போகும்போது increases. Is it clear? This is general trend. If you move from left to right, electron gain enthalpy increases. That means accepting tendency of an atom is more. Why? Accepting tendency of an electron is more. This is due to because of size. Because of size. Is it clear? Whereas down the group, you know, top to bottom. Top to bottom, you know. Top to bottom, electron gain enthalpy. Electron gain enthalpy decreases. But there is a change, small change. Okay, this is a general trend. Left to right, left to right. Again, this is another reason. Electron gain enthalpy. Electron gain enthalpy again is inversely proportional to atomic radius or atomic size. Okay, this also is going to be like similar to ionization energy. Similar to ionization energy. Left to right pona increase down the group pona decrease down. But there is a catch. Because third period is going to be more when compared to second period because of size. Because of size. Is it clear? So please you have to carefully answer this. And please note this. And all the elements, look at all elements way, that will have a negative electron gain enthalpy. And enthalpy? Enthalpy. Your magnitude element, your values element minus 300 something. Is it clear? Exact value, but you can check your NCERT. Okay, is it clear? Chlorine has a more magnitude in terms of negative. Chlorine has a more magnitude. Okay, electron gain enthalpy value is going to be more in terms of magnitude. Reason? Some 340 something. Please check it. Negative electron gain enthalpy in the period table A, which one has a more electron gain enthalpy? The answer is going to be group 17 elements. Group 17 elements. Is it clear? So you can easily accept the electron. Accept more. Accept more. What is electron gain enthalpy? What is electron gain enthalpy? So you have to take an isolated gaseous atom. Isolated gaseous atom. You have to introduce an electron. It will become X minus a mole. This is electron gain enthalpy. Is it clear? So electron gain enthalpy for group 17 is going to be more when compared to other group elements. So in this case is going to be more. Is it clear? So left to right element always has more electron gain enthalpy when compared to second period. This is because of size. And the rest is going to be rest of the element is going to follow the same order. Only there is a small change between. Okay, so that's the point you have to note down. Next important point, the fourth property is going to be electronegativity. Electronegativity. So electronegativity is also going to be electronegativity. Okay, it is inversely proportional to atomic radius, atomic size or atomic radius. Left to right pona increases, down the group on the decreases. If you move from left to right, electronegativity values are increasing. And we have discussed also fluorine electronegativity value. For fluorine, down the group on the decrease of Cl, Br, then I. Your electronegativity value is going to be 4 according to Pauling scale. This is going to be 3. This is going to be 2.8. This is going to be 2.5. Okay, it has a more electronegativity when compared to the other elements. So period table, which one is the highest electronegativity or more electronegativity? Fluorine. Answer is going to be fluorine. Okay, please note this trend correct, incorrect came on. Okay, next to the physical properties. Physical properties. Physical property. Physical property. First we are going to discuss about physical state. Okay. Next, the first one is going to be all halogens are colored. All halogens are colored. Is it clear? For example, F2. Okay, F2. Always halogen எப்படி exist ஆகும்? Diatomic தான் exist ஆகும். எப்படி exist ஆகும்? Diatomic. Is it clear? Yes or no? So fluorine is going to be, it's a gas. So the color is going to be yellow. Okay, the physical state is going to be gas. Cl2. This also is going to be a gas. The color is going to be greenish yellow. Greenish yellow. Is it clear? Next, Br2. What color are? What physical state are? Any idea? Liquid. Br2 is going to be a liquid. Br2 is going to be a liquid. So the color of this one is going to be a reddish brown liquid or reddish liquid. Reddish liquid. Is it clear? Next, last one, iodine. Iodine is going to be a solid. The color is going to be a violet or brown color. Is it clear? So these are the physical state. Is it a gas? Fluorine, chlorine is going to be gas. Bromine is going to be a liquid. Iodine is going to be a. Is it clear? So iodine எப்படி இருக்கும்? Granules இருக்கும். எத்தனை பேர் பார்த்துருக்கோம் iodine sample? Iodine. Iodine எங்கே பார்த்துருக்கோம் iodine? Iodine applications என்ன? சத்தமாக சொல்லுங்க. What is the applications? இதை டின்ச்சர் வச்சிருக்க டின்ச்சர் அடிபட்டா டின்ச்சர் இல்லையா அது என்ன கலர் brown color அது என்னது brown color due to iodine the brown color iodine is it clear the brown color is due to iodine is it clear next boiling point and melting point. Okay, boiling point and melting point. So what is the trick for this boiling point? Molecular weight or atomic number, is it clear? Molecular weight or atomic number or molecular mass or atomic mass, is it clear? Boiling point and melting point, okay, increases. Boiling point and melting point increases down the group. Increases down the group. Second point, solubility. 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 Boiling and melting point. Atomic mass, atomic number, down the group increase. Is it clear? Next, solubility. Br2 and I2. This is going to be sparingly soluble. Sparingly soluble in water. Sparingly soluble in water. But is completely soluble. More soluble. More soluble. More soluble in organic solvents. In organic solvents like CaCl3, chloroform, CCl4, carbon disulfide and hydrocarbon. Okay, so I2Br2 is sparingly soluble in water, whereas it is completely soluble or more soluble in organic solvents like chloroform, CCl4, carbon disulfide and any hydrocarbon solvents, benzene, whereas other than benzene, pentane, hexane. So is it clear? In the reactions use pannirkom? Your applications. Decolorization, is it clear? For example, எங்க ஆர்கானிக் யூஸ் பண்ணிருப்போம்? For example, suppose you take ethene, okay, Br2, என்ன solvent யூஸ் பண்ணிருப்போம்? Any idea? CCl4. என்ன solvent யூஸ் பண்ணிருப்போம்? CCl4, because CCl4 ல எது soluble? Br2 is more soluble. Br2 and I2, is it clear? என்ன ப்ராடக்ட் கிடைக்கும்? What product you will get? 1,2-dibromo ethane. Please note this. Br2 is more soluble in CCl4. Correlate பண்ண. Don't blindly read this. Okay, இது எங்க யூஸ் பண்ணுவோம்? bromination பண்ணிருக்கோம். அதுல என்ன solvent generally யூஸ் பண்ணுவாங்க? chloroform யூஸ் பண்ணுவாங்க. இல்ல chloroform இது CCl4 யூஸ் பண்ணுவாங்க. இல்ல carbon disulfide. Mostly CCl4. Is it clear? Next important physical property, bond dissociation energy. Actually, bond dissociation energy is very important. Bond dissociation energy, BDE, bond dissociation energy. So what is the expected order? What is the expected order for bond dissociation energy? Down the group ona, down the group ena size increase avuma, size increase ஆகும். சைஸ் இன்க்ரீஸ் ஆச்சுன்னா பாண்ட் லென்த் இன்க்ரீஸ் ஆகுமா? என்ன இன்க்ரீஸ் ஆகும்? பாண்ட் லென்த் இன்க்ரீஸ் ஆச்சுன்னா பாண்ட் ஸ்ட்ராங் பாண்ட் ஆகுமா, வீக் பாண்ட் ஆகுமா? இப்போ டவுன் தி குரூப் ஜெனரலி என்ன இருக்கும்? பாண்ட் dissociation energy is going to be less. Bond dissociation energy less. Is it clear? But in this case there is a small change. Please note this. புரியுதா? அப்போ bond dissociation energy என்னன்னா correct order is going to be இந்த ஆர்டர்னா Cl2. Okay, which has a more bond dissociation energy now among the halogens. Cl2 has a more bond dissociation energy. Apna meaning enna? What is the meaning of this? You have to supply. You have to supply. In order to break this bond, you have to supply more amount of energy. More amount of energy. Is it clear? Yes or no? Then followed by Br2. Then followed by F2. Then followed by I2. This is the order. Please note this. First la irundhu enga irukku third. Appo when compared to this one, idha bond dissociation energy order. Enna reason ah irukka mudiyum? What could be the reason? Why it has a less bond dissociation energy? Easy ah enna panikalam? Adala da enna pannirukkom appadina, for example, reaction of halogens with alkane, edu more reactive? Fluorine. But bond dissociation energy is going to be less. Why it has a less bond dissociation energy? Even at dark means no temperature, low temperature, even at a dark room, okay, that is more reactive, violent reactive. Why it is reacting violently with alkanes? You cannot control the reaction. Why? Because of the low bond dissociation energy. Why it has a low bond dissociation energy? Structure pane. Is it clear? The one reason is going to be, look at the structure. It has how many lone pairs? Fluorine has how many lone pairs? Octet. How lone pairs இருக்கும்? ஒரு lone pair, another 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 lone pair. Is it clear? அப்போ obviously இந்த lone pair என்ன இருக்கும்? Repulsion அதிகமாக இருக்கும். Repulsion is going to be more. Why repulsion is going to be more in the case of fluorine? Okay, இதுலயுமே எல்லாத்துலயும் lone pair தான இருக்கு, because small size. It has a small size. Due to small size. Due to small size. அப்போ due to small size இருக்கிறதுனால இதோட நியூக்ளியஸும் என்ன இருக்கும்? பக்கத்துல இருக்கும். அப்போ பக்கத்துல இருந்தது அப்படின்னா என்ன இருக்கும்? Size small இருந்தால் நியூக்ளியஸ் பக்கத்தில் க்ளோஸாக தானே இருக்கும். The nucleus is going to be very close to each other. as well as it has a lone pair. Lone pair na negative and negative repulsion இருக்கும் அதிகமாக இருக்கும். அப்போ இந்த பாண்ட் என்ன பண்ணிக்கலாம், ஈஸியாக பிரேக் பண்ணிடலாம். Okay, we can easily break this bond. எழுதிக்கோ, நோட் பண்ணிக்கோ. So எழுதிக்கோ, the bond dissociation energy of F2 is less than Cl2. The bond dissociation energy of F2 is less than Cl2. Bond dissociation energy of F2 is going to be less than Cl2 as large electron repulsion among lone pairs in F2. As large electron repulsion among lone pairs in F2. Large electrons repulsions among the lone pairs in F2. That's why it has a less bond dissociation energy when compared to Cl2. Okay, so please note this. In the diagram draw panniko, the large electron repulsion in the case of F2. Okay, you should be able to correlate. Okay, next, that's all about the physical property. Next we are going to discuss about chemical properties. அப்போ bond dissociation energy order கேட்டா you have to write only this is a correct order. Check பண்ணிக்கோ. Okay, correct incorrect ல கேட்பாங்க, you have to correct. Next, chemical properties. Chemical properties. Chemical properties. First, the anomalous behavior of fluorine. Anomalous behavior of fluorine. First point, anomalous behavior is all important. Listen carefully. Anomalous properties, exceptional, trend reverse ஆமாறது, exchange ஆறது. This order you have to remember. Is it clear? Always you have to question change வரும். Anomalous property, something exceptional, trend incorrect இருக்கிறது, ரெகுலரா இல்லாம இருக்கிறது, இதான் क्वेश्चंस இருக்கும். யூசுவலா வருது அதுவா क्वेश्चंஸா இருக்காது, ரிவர்ஸா வருது இல்ல ஆர்டர் சேஞ்ச் ஆகி வருது, அந்த மாதிரி தான் क्वेश्चंस இருக்கு. எலிகோ ஃபர்ஸ்ட் ரீசன், எலிகோ டியூ டு இட்ஸ் ஸ்மால் சைஸ். அனாமலஸ் ப்ராப்பர்ட்டிக்கு ஒரே ரீசன் தான். என்ன ப்ராப்பர்ட்டி சொல்லிருப்பாங்க? ஸ்மால் சைஸ். எலிகோ டியூ டு ஸ்மால் சைஸ், ஹை எலக்ட்ரோநெகட்டிவிட்டி. Due to small size, high electronegativity and low bond dissociation enthalpy or energy. Due to small size of the fluorine is going to be very small, high electronegativity. Third point is going to be a low bond dissociation energy and absence of vacant d orbital. Absence of vacant d orbital. Fourth point mudincha. The last point, the high value of electrode potential. High value of electrode potential. First point is why it shows anomalous behavior. Point number 1, small size, high electronegativity, low bond dissociation energy. Fourth one, absence of vacant d orbital. The fifth point is going to be a high electrode potential. High electrode potential. High electrode potential. Is it clear? Yes or no? You would have studied electrochemistry, no, right? Now that is clear. Yes or no? Yes. So F2, strongest or weakest reagent? Strongest oxidizing agent? Or weakest oxidizing agent? F2 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 strongest oxidizing agent, weakest oxidizing agent. Strongest oxidizing agent. What is the training? What is the training? Among the halogens, what is the training? Which one is the strongest oxidizing agent? F2, Cl2, Br2, I2. F2 is the strongest oxidizing agent among the entire electrochemical series. Among the entire electrochemical series. Oxidizing agent meaning is it oxidizes others, but itself reduce. Reduce on an equation. What is the equation you can write? F2, it will take 2 electron. It will become 2F minus. Okay, so any halogen will take 2 electron. It will become 2X minus. Okay, oxidizing agent others is oxidize itself reduce it has a more value. This SRP value positive or negative or SRP value positive or reduction easy oxidizing agent, is it clear? Your value is approximately 2.83, I think so, 2 point something, but it has a greatest value. Please check this value. 2.8 or 9, 2.8 or 3 in the value, you please check. Is it clear? About electrochemical series, which one is the strongest oxidizing agent? F2. Order F2, Cl2, Br2, I2. Among this one, is the strongest oxidizing agent? F2 is the strongest oxidizing agent. Strongest oxidizing means it is a good electron acceptor. Good electron acceptor. Reducing agent good electron donor. Good electron donor. Please note this. For example, anomalous reason property size, electronegativity, then low bond dissociation enthalpy because due to the lone pair repulsion. The last one is going to be absence of vacant d orbital. The fifth point is going to be a high value of electrode potential or high electrode potential value. SRP value is going to be next. Will go next. Second point will go. Second, most reactions of fluorines are exothermic. Most reactions of fluorines are exothermic. Yes or no? Most reactions of fluorines are exothermic. Due to small size and strong bonds formed by it. Most reactions of fluorines are exothermic. Exothermic na pakkathula delta H is going to be negative. Due to small size and strong bonds formed by it. Second point, it forms only one oxo acid. Strong bond formed by it. Small size and strong bond formed by it. Second, next point will go. It forms only one oxo or oxy acid. Oxo acid. It forms only one oxo acid. Apna meaning hai? What is meant by oxo acid? What is meant by oxo acid? Huh? What is meant by oxo acid? Oxo acid means, for example, you please note this. For example, in the case of phosphorus, we discussed, but it's a deleted portions. But HCl I படிச்சிருப்பேன். Is it clear? Listen. In the case of oxo acids of phosphorus, listen carefully. Phosphorus delta means double bond O, OH, inga hydrogen, inga hydrogen. Is it clear? This is one of the oxo acids of phosphorus. This is one of the oxo acids of phosphorus. இது எப்படி சார் நம்ம ஐடென்டிஃபை பண்ணோம் அப்படின்னா listen carefully. We have a OH bond இருக்கணும். இந்த மாதிரி ஃபார்மட்ல இருக்கணும். E ஈக்குவலா இருக்கு பாஸ்பரஸ் இருக்கு. ஸோ அந்த ஈல இருக்கணும் ஒரு மல்டிபிள் ஒரு டபுள் பாண்ட் கண்டிப்பாக இருக்கணும். அண்ட் இன் அடிஷன் டு தட் யூ ஷுட் ஹேவ் ஒன் OH. இந்த மாதிரி ஃப்ரேம் ஒர்க் எங்கெங்கெல்லாம் இருக்கும் தட் இஸ் ஆல் கால்ட் ஆக்சோ ஆசிட்ஸ். ஓகே, என்ன இருக்கணும்? OH இருக்கணும். இந்த OH எங்கே அட்டாச் ஆயிருக்கணும்? ஒரு லெஸ் எலக்ட்ரோநெகட்டிவ் ஆட்டத்தோட அட்டாச் ஆயிருக்கணும். ஃபார் எக்ஸாம்பிள் பாஸ்பரஸ் இதோட லெஸ் எலக்ட்ரோநெகட்டிவ், ஆக்சிஜனை விட லெஸ் எலக்ட்ரோநெகட்டிவ். அது காமனாக எழுதிக்கலாம், ஈன்னு எழுதிக்கலாம். அதில் என்ன இருக்கணும்? ஒரு டபுள் பாண்ட் ஓ இருக்கணும். அப்படி இருந்தால் அதுக்கு பேர் என்னது? ஆக்சோ ஆர் ஆக்சி ஆசிட் இல்லைங்களா? ஆக்சோ ஆசிட். அப்போ இது ஆக்சோ ஆசிட். இஸ் கிளியர்? இதோட ஃபார்முலா என்ன? H3PO2. இதுக்கு பேர் என்னது? ஹைப்போ பாஸ்பரஸ் ஆசிட். இதுக்கு பேர் என்ன? பாஸ்பரஸ் ஆசிட். அப்போ ஆக்சோ ஆசிட்னா மீனிங் புரியுதா? இஸ் கிளியர்? என்ன இருக்கணும்? ஒரு டபுள் பாண்ட் ஓ இருக்கணும், பிளஸ் என்ன இருக்கணும்? ஒரு OH. இதுக்கு பேர் என்னது? H3PO2. இதுக்கு பேர் என்னது? ஹைப்போ பாஸ்பரஸ் ஆசிட். என்ன ஆசிட்? HCl நீ படிப்பேன். Next, suppose this is going to be a OH, this is going to be a hydrogen. இது ஆக்சோ ஆசிட்டா இல்லையா? ஆக்சோ ஆசிட்டா இல்லையா? Yes, because என்ன இருக்கு? டபுள் பாண்ட் O இருக்கு, OH. இது ஃபார்முலா என்ன? H3PO3. Is it clear? இதுக்கு பேரு பாஸ்பரஸ் ஆசிட். இதுக்கு பேர் என்னது? Phosphorus. இதுமே was one of the oxo acids of phosphorus. Similarly, you can take this one. Is it clear? இதுக்கு பேர் என்ன? Double bond O as well as we have OH. இதுக்கு பேர் என்னது? H3PO4. இதுக்கு பேர் என்ன? Orthophosphoric acid. இதுக்கு பேர் என்ன? Orthophosphoric acid. இந்த மாதிரி இதுவும் என்ன ஃபார்ம் ஆகும்? It will form only one oxo acid. இந்த மாதிரி நிறைய ஃபார்ம் ஆகாது. It will form only one oxo acid. Is it clear? Next, shall we go? Whereas other halogens forms large number of oxo acids that I will discuss. Next point. Other halogens forms a lot of oxo acids that I will discuss. Okay. Third point, HF. Very important. HF is a liquid below 293 Kelvin. Very important point. HF is a liquid. Okay. Liquid below 293 K. Below 293 K due to strong hydrogen bonding. Due to strong hydrogen bonding. Strong hydrogen bonding. அப்போ HF கம்பேர் பண்ணும்போது we have to go for HF, HCl, HBr, HI. Is it clear? இதில் எது லிக்விட்னு கேட்டால் HF is going to be liquid. The remaining all இதெல்லாம் என்னது? Gas. சரிதா? Only this ஹாலைட்ஸ்ல இது மட்டும் லிக்விட் கேட்டா HF is going to be liquid because இதுல மட்டும் தான் என்ன பாண்ட் இருக்கும்? ஹைட்ரஜன் பாண்ட். இதுல என்ன கிடையாது? ஹைட்ரஜன் பாண்ட் கிடையாது, ஹைட்ரஜன் பாண்ட் கிடையாது, ஹைட்ரஜன் பாண்ட் கிடையாது. அதெல்லாம் என்ன எக்ஸிஸ்ட் ஆகுது? அப்போ பிசிக்கல் ஸ்டேட் மாறுது if you have ஹைட்ரஜன் பாண்ட். பிசிக்கல் ஸ்டேட் லிக்விட் கேஸ், மற்றது எல்லாமே ஹைட்ரஜன் பாண்ட் இல்லாதனால கேஸா இருக்கு. லைக் in the case of H2O and H2S. H2O, H2S. இதுல எது லிக்விட், எது கேஸ்? H2O, H2O gas. H2O is going to be liquid, H2S is going to be gas. Is it clear? Similarly, in the case of HF is a liquid, the rest is going to be இதெல்லாம் anomalous behavior. Is it clear? Next is going to be oxidation state. Anomalous behavior la இது ஏன் anomalous behavior exhibit பண்ணுதுன்னா reason is 5 reasons. என்ன reason? Small size, high electronegativity. இதுல எக்ஸ்ட்ரா பாயிண்ட் என்ன ஆட் பண்ணிருக்கோம்? low bond dissociation enthalpy. என்ன எக்ஸ்ட்ரா பாயிண்ட் ஆட் பண்ணிருக்கோம், இன்னொரு பாயிண்ட் high value of electrode potential. High value of electrode potential. Is it clear? Yes. Next, we are going to discuss about oxidation state. Oxidation state. Oxidation state. Oxidation state. Is it clear? So all halogen exhibit -1 oxidation state. All halogens exhibit -1 oxidation state. In the statement correct or incorrect? All halogen exhibit -1 oxidation states. Correct or incorrect? Correct or incorrect? எப்படி justify பண்ணுவ? எப்படி justify பண்ணுவ? All halogen exhibit -1 oxidation state. Examples. HBr, HF, HCl, HI, NaI, NaBr, NaCl. Is it clear? Yes or no? All halogen exhibit -1 oxidation. There you go. All halogens exhibit -1 oxidation state. However, Cl, Br and I, it exhibits +1, +1, +3, +5, +7. Okay? Is it clear? இதில் என்ன பாயிண்ட் எடுத்துக்கலாம்? எது மட்டும் தான் நான் எழுதியிருக்கேன்? Cl எழுதியிருக்கேன், Br எழுதியிருக்கேன், I. அதில் என்ன in addition to -1 என்ன ஆக்சிடேஷன் ஸ்டேட்லாம் அவைலபிள் இருக்கு? +1, +3, +5, என்ன எலிமெண்ட்? Fluorine ஒரே ஒரு oxidation state is going to be -1. Why? Why fluorine has only one oxidation state? High electronegativity. Fluorine shows only one oxidation state, that is going to be. But fluorine always exhibit or always shows only one oxidation state, that is going to be -1. Okay, -1. அப்போ அதுக்கு என்ன ஆக்சிடேஷன் கிடையாது? பாசிட்டிவ் ஆக்சிடேஷன் ஸ்டேட் கிடையாது. +1, +3, +5 எல்லாம் கிடையாது. Whereas the other elements can oxidation states are possible. These are the oxidation states are +1, +3, +5. Is it clear? Is it clear? Time. Remaining I will discuss. Yeah, with this I will stop. Any doubts, corrections, class please? I think time up, right? Boys, you can move.